And then obviously our robotic inspection, and I think I've got about 15 minutes here to focus on this, so at the very most, so I'm going to go pretty quickly. We acquired this company in the year 2007 from Prax Air Services. Prax Air Services had acquired it from Riverstone Carlisle Group, which was a very, very, very large private equity group out of New York, and Mitsubishi Heavy Industries, which had been heavily involved in the development of this technology. This technology was originally developed for the nuclear industry to facilitate the inspection of water storage tanks at nuclear facilities. And we ended up acquiring it in 2007 and have been extremely successful with it within the oil and gas, petrochemicals, refining, power plant industry overall. So again, created in the early 1980s with a focus on the utility industry. We refocused it onto above ground storage tanks in the year 1995 because of the API 653 requirements that required tanks to be taken out of service every 10 years. It was accepted by API 653 around the year 1998, and we have 5 patents granted on the technology. We've completed over 1,000 inspections. We have hundreds of clients. In fact, I think the AES guys in Puerto Rico had used this about a decade ago. So I probably have some old reports if you'd like to see them. We have 3 crews. As I said, we have 1 in the Middle East and India. We have 2 here in the United States. So anywhere else that we travel, we would have to mobilize that equipment. And we acquired the business in June of 2007. So we talked about the economic factors. I'm not going to go into those again. But long story short, inspection of a storage tank is about 1% of the total cost to remove that storage tank from service. We're able to address that with a robotic solution. Now, keep in mind, and I have to disclose this, if you know the tank is in bad shape and you know that you have an issue with the floor possibly leaking, please don't use this solution. Okay, please remove the tank from service and inspect it using out of service techniques and repair the tank. I can't tell you how many times we've found clients that want to utilize this technology to address tanks that are already leaking. It's not a good use of this technology. So if the goal is to be compliant with federal or state regulations, or to achieve the deferral of a tank inspection to a point later in time using risk-based analysis, then this would be the solution to utilize. So I just have to disclose that to you guys, and there's a reason behind that comment. So API recommended practice 575, tools for internal tank inspection used while the tank is in service have been developed. Robotic crawler devices are designed for total immersion into liquids. We've used these on naphtha, gasoline, jet fuel, number 6 oil, many fuel oils, some condensate. And let me repeat, I made a mistake when I said we use it on gasoline. We don't actually use our systems on gasoline, so just keep that in mind. I don't think you guys have many gasoline tanks, and I doubt that's an issue. But the technology has been utilized in a wide variety of products, including but not limited to crude, diesel, jet, fuel, gasoline, lube, oil, benzene, hexane, boiler feed water, and chemicals. So just some information for you. So verbatim, statistical methods are also available for assessing the probable minimum remaining thickness of the tank bottom, and the methods are based on sampling thickness data. The number of measurements taken for statistical sampling will depend on the size of the tank and the degree of soil-side corrosion found. This is important because when we put our robots into these tanks, we're scanning about 5% of the floor. Again, I repeat, only 5% of the floor. If we were to scan 50% of the floor, we would be in those tanks for months, and it would be extraordinarily expensive to collect that much data. So with ExxonMobil, we worked with them and they came up with a concept of using extreme value analysis, which is a statistical model, which API has approved for in-service storage tank inspection. And basically we take the 5% of data collected, and we statistically analyze that data to identify the most probabilistic largest defect that would be in the tank based on the millions of random thickness readings collected on the floor. And using that theoretical corrosion rate and likely thickness rating, we can calculate the reinspection interval according to API 653. So we do the same process to calculate reinspection and remaining life as 653 does, but we're using a statistical model to identify the largest possible defect on the floor itself. So all that in mind, if we're going to do an in-service tank inspection, there's basically 8 phases to the process. The very most important phase to us is we pre-qualify the tank. We have a questionnaire that we would send to you, and we would ask that you fill it out to the best of your knowledge. There's a lot of information we need to understand to determine if the application of robotics in your tank is even a potential. For example, if the tank has heating coils on the floor, we really don't want to put a robot in a tank with a bunch of heating coils. So knowing that a heating coil exists would be important. Noting that the roof itself is in bad shape is not a good thing for us, because if the roof is in bad shape and we put a 1,000-pound robot on the roof, there's a possibility it could fall through. So we might have to ask you to develop scaffolding or some other form of support so that we could establish our equipment on the roof of the tank. So the point being is this pre-qualification stage is the most important part. Then obviously our proposal is going to be based on the information you provide us. So if your information is inaccurate, our proposal will likely be inaccurate, and then everybody's going to be upset. So we ask that you be very open and honest with us about what the condition of the tank is. Once we all agree and there's a PO issued, then we will develop the logistics to move this equipment to the location. In the United States, we typically just throw it on the back of a large trailer and have a trucking company deliver it to site. Overseas, we might put it on a ship inside a shipping container that arrives to the port in Punta Arenas, for example, and then from there they would drive it to the site. After it's arrived to the site, then we'll obviously, the personnel would arrive, we would do all of the on-site briefing, get everybody prepared for the actual project. We ask that the client provide a crane, and the crane is necessary only for the first day and for the last day. And that's necessary in order to rig the equipment up to the roof of the tank. So the robot itself is only about 400 pounds. The umbilical is about 350 to 400 pounds, depending on how large the diameter tank is. The bottom of the robot has an ultrasonic thickness system. So here's just an example of one of the robots. So we use transponders. So there's 2 transponders on the robot. We have a sonar system on the robot. And the transponders allow us to navigate, to triangulate the position of the robot in a tank. The sonar allows us to avoid obstacles in the tank, such as a sump or legs or something of that nature. There's an umbilical on the back of the tank. There's a camera system. If it's a clear product, we can do a visual inspection. We have a brushing system and vacuum on the bottom of the robot, and then an array of 8 transducers on the bottom too. So this is just a depiction of the robot in the tank, the navigation transponders, the receivers, the ultrasonic transducers on the bottom, vacuum, and we just drive within the tank and identify areas where there's corrosion. So this is an example of where the robot is deployed through the roof onto the floor of the tank. This is an example of our Otis system that we typically use in very clean storage tanks. This is an example of an array of ultrasonic transducers on the bottom of the robot. This is the arrangement of those transducers on the tank floor. The idea being that we'll capture the corrosion. We could differentiate whether it's top side or bottom side corrosion. And then basically we take 8-foot long, 7-inch wide scans over the floor of the tank. So we're typically obtaining 1 scan, 2 scans per floor plate. And then utilizing our extreme value analysis, we're able to take 200 to 1,000,000 thickness readings, and using distribution determine the maximum metal loss indication, and then basically calculate the minimum thickness and remaining useful life from that. So this is just a quick presentation, obviously. I've got a quick video here, but I mean, you can find this on our website, obviously, if you want to download it, or we're on YouTube. Can you hear this?
Are you behind on inspection?
Aisel, are you able to?
Yeah, we can see video and we can hear, but it's
Okay.
maybe you can.
Challenges and uncertainty for your
Hey,
organization.
and we're just talking about the uncertainty associated with storage tanks and significant costs associated with managing these assets,
While the inspected tank remains
and that we can deploy this while the tank remains in service.
TechCorr's robot tank inspection system is lifted to the tank.
We lift the robot to the roof of the tank.
Then inserted via the tank's mainway.
Robot.
Utilizing high-efficient navigational systems, the robot operator can pinpoint the robot's location, and sonar is used to identify and avoid obstacles during navigation. The robot is also equipped with a submersible pump, which allows floor sediment to be vacuumed.
So we use the pump that's on the robot to move the sludge inside the tank to behind the
collected
robot.
data is then analyzed and plotted to differentiate between bottom side and top side corrosion.
And we're able to differentiate between bottom side and top side corrosion.
Depending on tank size, several million thickness readings may be recorded during the inspection. TechCorr's unique
And
technology
we'll take
approved by
several
API
million thickness readings in the storage tank.
federal and state regulatory requirements, and allows tank operators to make informed decisions about a tank's remaining floor life, reinspection interval, retirement date, and risk tolerance. Contact TechCorr today to discuss our cutting-edge technologies and find out how TechCorr helps its clients smoothly, safely, and cost-effectively manage their.
So hopefully I at least grabbed your attention that there's a solution out there for the inspection of storage tanks while they remain in service. It may not be the perfect solution, but honestly, I think it's one of the best solutions out there if your interest is to achieve compliance or attempt to defer the inspection to a later date where you might have more money in your budget. And if you ever have any interest or have any projects where you might want to try to utilize this technique, we'd be happy to support you and provide a quote. If you have any out-of-service tank inspections, we're extremely good at storage tank inspection while the tanks are removed from service. I can share some example reports with you if you'd like. And then obviously if you have any boiler outages where you need a team of individuals that are qualified in taking thousands of thickness readings, we can provide those, or even the condenser inspections using eddy current. So anything you need, please keep us in mind, and I'm very grateful, Aisel, for allowing us to give this presentation. Unfortunately, I think we've run out of time and we won't be able to focus on the UAVs, but we have two systems, one that is inside a cage that we use within confined space, and another system that includes infrared and LiDAR for mapping
and corrosion
measurement.